Let's do IXL 8th grade W11. Go to Learning. Make sure you're on Math. Then go down to 8th grade W. Where's W? I know you're here somewhere. Ah, there it is. W11. Solve equations with variables on both sides. Okay, so let's go to Frydman Math. And for this exercise, we are going to need to know how to combine like terms. I'm actually not sure if we're going to need distribution here. I don't know if they're going to give us any distribution problems. We'll just talk about that briefly anyway. And solving equations. So pages 6 and 7. Let's just read through a little bit. We're not going to read every little thing. So like terms are terms that all have the exact same variable or variables raised to the exact same exponent or exponents, or terms that all do not have a variable. So for example, this term over here is a like term with this term over here because they both have m to the 4th power. Okay? Sometimes when we're talking about terms, some people say that this is the term, and other people say that, no, this is the term. So some people include the minus sign when they talk about what the term is. Some people don't include the minus sign or the plus sign. I actually, to be honest, I go back and forth, and sometimes I'll include it, and sometimes I won't when I'm talking about it. So basically, when we're combining like terms, we are adding or subtracting the term. So I guess technically it would be better to say that just this is the term which we are subtracting from this term. Okay, so combining like terms means that we either add the terms or we subtract the terms. That's all that it means. And when we do that, the variable and the exponent stay the same. It's only the coefficient, the number that's in front of the variable, which would change. So for example, 35 minus 5 is 30. So we get 30 m to the 4th there. Okay, and we could combine more than two terms. However many terms there are that are like terms, we should combine all of them. And when we distribute, it just means we're taking what's in front of the parentheses and we're multiplying. Whoa. And we are multiplying it with every term inside the parentheses. And you have to pay close attention to signs here. So for example, this 4, that's a positive 4, times this technically is minus 16, but we would think of it, you can think of it as a negative 16 because it's the same thing as plus negative 16. So positive times a negative would be negative. So over here, this last term would be minus 64j. Again, we're sort of using minuses and negatives interchangeably here. All right, so that's a very quick review of combining like terms and distribution. Now for solving equations, remember our goal when we solve equations is to figure out what value makes the equation true. So for example, 30 equals x plus 20. What number here, plus 20, is equal to 30? Well, that answer is 10. Hopefully everybody knows 10 plus 20 is 30. So, but how would we figure that out sort of systematically? We would do that by using inverse operations and doing the same thing on both sides. So by inverse operations, we mean if we're trying to get rid of a number that's being multiplied, we would divide that number. If we're trying to get rid of a number that's being added, we would subtract that number. So multiplication and division are inverse operations and inverse to each other, and addition and subtraction are inverses to each other. All right, and we also keep things equal. So if we are using inverse operations, or if we are changing one of the sides of the equation in some way, then we would have to change the other side of the equation in the exact same way so that both sides are still equal. So for this example over here, we have this plus 20. We want to get rid of that so that the x is by itself. So we'll use inverse operations. So the inverse of addition is subtraction. So we will subtract 20 from both sides. And then the x is by itself, and we have on the left side 30 minus 20 is 10. So x is equal to 10. And to check our answer, we just plug it back in. And yes, 10 plus 20 is equal to 30. So we get 30 equals 30. That's good. So we put a check mark there. Okay, and you can read through this also. If you need a little bit of a refresher, I'm not going to read through the whole thing right now. Let's just do some IXL problems. So solve for B. I'm going to rewrite the whole thing over here so I have some space to work with. B keeps doing that. I'm just going to rewrite this whole thing over here. B equals 9b minus 8. Okay, so we want all of the b's to be on the same side of the equation. So we have a b on the left side, and we also have a b on the right side. So how can we get the b's to all be on the same side of the equation? Well, what we could do is take this 9b and actually subtract that from both sides. Because this 9 here, remember, you can put in an invisible plus sign there. And then to take this term 9b away from the right side, we can subtract it away because the inverse of addition is subtraction. So we'll write minus 9b and then do the same thing to the other side where there is another b term. So we'll write minus 9b over here also. So this cancels out, and we still have this minus 8 will just now becomes a negative 8 equals, don't forget to copy the equal sign. Now this b here is like 1b. So we have 1b minus 9b is equal to negative 8b. 1 minus 9 is negative 8. And now these things are actually getting multiplied together, so the inverse would be division. So we would divide both sides by negative 8. And we get b equals negative 8 divided by negative 8 is negative divided by negative. You can look at, on Frydman Math, you can look at page, I forget what page it's on. Where's negatives? I remember, it's page 5. Okay, look at the rules for negative numbers if you can't remember. Okay, there are rewriting rules, there are adding and subtracting rules, there are multiplying and dividing rules. So right now, I'm dividing a negative divided by a negative. Negative divided by a negative is positive. So we'll put a positive 1 here, and 8 divided by 8 is 1, so I get a positive 1. So b is equal to 1. Now, I can check that by plugging back in. So let me write this whole thing again. B equals 9b minus 8. And if b is equal to 1, let me plug a 1 in wherever I see b. So I have 1 equals 9 times 1 minus 8. So 9 times 1 is 9, and 9 minus 8 is 1. So I get 1 equals 1, which is true, so that's good. The answer here is 1. Okay, z equals negative 2z plus 9. Again, I have a z on the left and I have a z on the right. I want my z's to all be on the same side. I can do that here by adding, since this is, technically it's a negative, but I can think of it like subtraction, and I can do the inverse of subtraction, which is addition, and I can add 2z to both sides. So that cancels, and I get 9 equals, this is like 1z, so 1z plus 2z is 3z, and then this is multiplication here, so I need to divide both sides by 3 to cancel this out, and I get z equals 9 divided by 3 is 3. Now let's check that. Let's write our original equation again. Z equals negative 2z plus 9. So z is equal to 3. Let's see. 3 equals negative 2 times 3 plus 9. 3 equals negative 6 plus 9. 3 equals, and negative 6 plus 9. These are different symbols. So again, if you can't remember, go back to the reference page. Different symbols subtract and take the symbol of the larger number. So if I subtract these numbers, and 9 minus 6 is 3, and I take the symbol of the larger number, 9 is bigger than 6, that had a plus sign in front of it, so I would get a positive 3 on this side. And I also had a positive 3 on the left side, so I get 3 equals 3, which is correct. So z here is equal to 3. Okay, I actually don't like the fact that this number here turned out to be the same as this. I want you to understand I'm putting a 3 in this answer box because of this 3 over here, because z turned out to be equal to 3. I'm not putting a 3 over here because of these 3's down here. It's because of this one. That's why I'm putting it over here. This was just a check to make sure that z equals 3 actually does satisfy the equation. All right. Let's try another one. 8 plus 5w equals 4w. We will subtract 5w from both sides. Why am I doing that? I'm doing that because that's going to get rid of it on the left side. So now all of my w's will be on the right side, and I have no w's on the left side. Remember, this IXL exercise is going to give you the variable on both sides. Really, I should say the unknown on both sides. You have to get it to one side. And then from there, solving it is a lot easier. So 4 minus 5, be careful. This is not 5 minus 4. 5 minus 4 would be 1. 4 minus 5 is negative 1. So we have negative 1w, which is like negative 1 times w. So we can do the inverse of multiplication, which is division, and we can divide both sides by negative 1, and we get w equals. Now I have a positive divided by a negative, which is negative. And 8 divided by 1 is 8, so I get negative 8. Okay, I'm going to check this. I think this is going to be the last problem that I check on the side. You don't always have to do the check, but it's good to do the check to make sure that your answer is correct. So if I actually plug in -8 everywhere that I see a W, okay, and then when I multiply these things 5 times -8, I'm going to get -40. So I have 8 plus -40 equals 4 times -8 is -32. Then plus negative becomes minus. So I have 8 minus 40 equals -32. And 8 minus 40 is -32. So I get -32 equals -32. That's good. Okay, so that tells me that -8 does work. So let's put a -8 over here. All right, we'll do one more like this, and let's see if it gives me anything different on the next level. -6s equals -5s plus 5. I want to get both of my s's to the same side. So I will, since this is technically a negative sign, but I'll think of it like subtraction. So I will do the inverse of subtraction, and I will add 5s to, whoa, not 58. 5s to both sides. Here I have -6 plus 5. So different symbols subtract. 6 minus 5 is 1, and keep the symbol of the larger number. 6 is bigger than 5. It had a negative in front of it, so we'll put a negative over here. So I'm going to have -1s on this side equal, that's an s, not a 5. These are all s's, equals 5 on this side. Now this is like -1 times s, so we will divide both sides, which is the inverse of multiplication. Divide both sides by -1, we get s equals positive divided by negative is negative, and 5 divided by 1 is 5, so I get s equals -5. I'm not going to do the check. I'm just going to put in -5. All right. Okay, good. I will do this problem because it's a little bit different. We have -9 minus m equals m plus 9. Okay. Now I can choose whether I want to put all the m's on the left side or the right side. Actually, I could have done that in all of the other problems also. But in the other problems, well, never mind. The other problems were easier because there was only an extra number on one of the sides of the equation, never mind. I'm confusing people now, so forget it. Anyway, so I'm going to choose to put the m's on this side. So I'm going to, remember, this is like 1m and this is like 1m. So I'm going to get rid of this m over here, and I'm going to move all the m's over to this side. So this is subtraction. I will add 1m to both sides. Now, if I'm adding 1m, should I add it to this term, or should I add it to this term? Answer, I should add it to this term. Why? Because I can only combine like terms. Remember, combine means add or subtract. I can only add or subtract like terms. This and this are not like terms because this has an m and this does not. But this and this are like terms because this has an m and this has an m. And neither one of them have an exponent. Okay, so they are like terms. So I'm going to do another plus 1m, not over here, but over here, because this term also has an m. Now these cancel out. Negative 1 plus 1 is 0. It's gone. And we have negative 9 equals, this is not negative 1 plus 1. This is positive 1 plus 1, which I know is a very difficult question. 1 plus 1. It's okay if you use a calculator if you need to for that one. It's tough. 1 plus 1 is 2. I actually looked that up earlier, so I'm pretty sure that it's right. So 1 plus 1 is 2. So I have 2m over here plus 9. Now I would solve this just like I would solve a normal equation with the unknown on one side. I can subtract 9 from both sides, so that cancels this, and I have 2m equals negative 9 minus 9. So now I have same symbols, so I will add 9 plus 9 is 18 and keep the symbol. So I get negative 18 there. Now 2m, this is like 2 times m, so I'll divide both sides by 2. So now I have m equals negative divided by positive is negative, so I get negative 9 there. So m is equal to negative 9. Right? Again, just remember to put a 1 in front of both of these d's. Okay, I'm going to jump ahead to the next level to see if I get something different. Okay, yeah. So over here, let me make sure I copied that right. Negative 8c plus 10 equals negative 8 plus 7c minus 6c. Okay, good. So notice that this c term and this c term are both on the same side. So I can go ahead and just combine them right away. Do not combine terms that are on different sides of the equal sign. Remember, the equal sign is what separates the two sides from each other. So do not combine, let's say, this term with this term, because they're on different sides. But you can combine this term and this term because they are on the same side of the equal sign. So positive 7 minus 6 is 1. So we would get, I'm not using inverse operations now. I'm just combining these terms here. So I'm going to rewrite everything else exactly the same way as it was before. Negative 8c plus 10 equals negative 8. And again, positive 7 minus 6 is positive 1. So I'll write plus 1c. All right. Now I have a c term over here and a c term over here. Can I combine these things like I did before with these terms? No, absolutely not. Because you don't want to cut across this line here. You cannot combine terms that are on different sides of the equal sign. Oh, I mean, you can't combine them just simply like that by doing negative 8 plus 1. You can't do that. But what we can do, like what we've been doing, is we can use inverse operations. And since this is a +1, we'll put minus, let me use blue, minus 1c, and then do a minus 1c on the other side also. Now think, where am I going to put the minus 1c? Am I going to put it under this term, or am I going to put it under this term? The answer is I'm going to put it under this term because this term has a c and this term has a c. Okay? That's very, very important. So I'll put the minus 1c under here. And let's see what I get. These cancel out. I have -8 equals same symbols, add and keep the symbol. And also keep the unknown. Don't worry. Forget about the c there. And the 10 stays the way it was, so +10. Okay, so now the rest of this is just like solving a pretty simple equation. So subtract 10 from both sides. That cancels. We have -9c here equals, once again, same symbols, add, and keep the symbol. Now this is like -9 times c, so we'll divide both sides by -9. C is equal to a negative divided by a negative is positive. So C equals +2. And you know what? I will go ahead and just plug that in to the original equation just to check it. So I'm going to rewrite everything, except wherever I see a C, I'm going to write 2. So that would be -8 times 2 plus 10 equals -8 plus 7 times 2 minus 6 times 2. So that's going to give me -16 plus 10 equals -8 plus 14 minus 12. This is going to give me different symbols, subtract, and take the symbol of the larger number. Equals -8 plus 14. Different symbols, subtract. 14 minus 8 is 6. And take the symbol of the larger number. That's a plus. 14 is bigger than 8, so +6 minus 12. And now 6 minus 12 is -6. So I get a -6 on this side equals -6 on this side, so that's good. So C equals 2 is correct. Okay. Let's go ahead and jump to the next level. This is also pretty much the same as what we had before. Is there something different about this one? Oh, no, not really. So I'll do it anyway just because I want to do a lot of examples because I know that this takes practice. Okay, so it really doesn't matter if we want to move these t's over here or these t's over here. I'm saying these because I have 9 of them over here and 14 of them over here. So let's just do -9t. And again, ask yourself, where should we put the -9t on this side? Should we put it under this term or should we put it under this term? Answer, we should put it under this term because this term has a t just like this term has a t. Okay, so we'll put -9t over there. And we have 5t plus 20 equals -20. Now I want to get the t by itself. I'll subtract 20. And I have to do the same thing on the other side also. So that cancels 5t. Same symbols, add, and keep the symbol. Now this is like 5 times t, so divide both sides by 5. We get t equals negative divided by positive is negative. 40 divided by 5 is 8. So t equals 8. Whoa, what did I do? Oh, I forgot to put the negative in. I did have it written there. Oh, man. Okay. Remember, if you make a mistake, then please look at the explanation. All right. IXL is not going to write the explanation in exactly the same way that I wrote it, but they're just going to say in words what they did. So in other words, to get from here to here, they subtracted 9t from both sides. So that's what I did as my first step over here. I subtracted 9t from both sides. So we're solving it in the same way. Whoops. And then to get from here to here, they subtracted 20 from both sides. So that canceled it out over here, and then they got negative 40. That's the same thing that we did over here. So they're just writing things in a different way. So whatever you see written over here, that's how they got from the previous line to that line. So subtract 9t from both sides, that's how they got from this previous line down to this line that's right next to the words there. Okay. I'm going to jump to the next level. This seems to be just like what we've done before, so I'm going to jump to the next level again. All right, so now we have decimals. So it's exactly the same thing, just with decimals. So let's do one with decimals. 5.9u minus 13.44 equals 7.5u. So this is like plus, there's like an invisible plus sign there. So we can subtract 5.9u from both sides. Don't forget to copy this sign over here. Negative 13.44 equals. Now this is just an elementary school problem. Okay, 7.5 minus 5.9. Remember to line up the decimals. I already lined them up here. It's going to be in the same place in the answer. 5 minus 9, I can't do that when I'm calculating with decimals like this. So I can't take 9 away from 5. I'm going to have to borrow from the 7. That becomes a 6. Put a 1 next to the 5. 15 minus 9 is 6. And 6 minus 5 is 1. So I get 1.6u over here. Now I can go ahead and divide both sides by 1.6. So I get u equals, and what would that be? Not sure. So anyway, so we can use a calculator for that one. 10, 11, 12, 13, 14, no. Maybe 9. Okay, 13.44 divided by 1.6, I think 9. Oh man, okay. I just assumed that it would give me an integer, a whole number. Just because for a lot of these IXL problems they work it out that way. But no, that was would have been my best guess if it for a whole number, but I was just wrong. Okay. let's not sugarcoat it. I was just wrong. Okay, so anyway, 13.44 divided by 1.6 is 8.4. But remember, in the calculator, I didn't take into account negatives. So a negative divided by a positive is negative. So we'll write negative 8.4. Yeah, that would, let's see. No, that would have been 14. So 1.6 times 9 would have been 14.4, right? 1.6 times 9 is 14.4. Yeah, so not 13.44. So that was a bad guess. All right. Anyway, so our answer here is negative 8.4. There we go. Okay. So another problem. You know what? Let's do this one actually just because of the first step. Negative 19.98. I'm going to run out of space here. Let me start a little bit further to the left. Negative 19.98. All right, did I do that? Did I copy that correctly? Okay. Now, again, the equal sign is what separates the two sides of the equation. And notice that I have terms on this side which I can combine because this does not have an unknown next to it, and neither does this. So we can combine these two terms. Remember, same symbols, add and keep the symbols. So once again, I'll go to the calculator, and I'm not going to embarrass myself this time by guessing what the answer is going to be. So I'm just going to type that into the calculator. 19.98 plus 17.86, 37.84. But remember, I have to keep the symbol. So I'm going to get negative 37.84. There's no W there. And then minus 12.9 W. That's just from right here. I'm just copying it down. Now, it is actually okay to do it the other way also. If you want to put the 12.9 W in front of the negative 37.84, you could do that also. Either way would be correct. As long as you make sure that there is a negative or minus in front of this term, and there's also a negative or minus in front of this term, then the order that you arrange them in will not matter. And that really follows from the commutative property of addition, even though it's hard to see why it's addition here, because it doesn't look like addition. But it is the commutative property, which is allowing us to rewrite that in any order that we want. All right. I'll just say, okay, so it's, well, okay. I won't go into an explanation of that, but let's just continue. So negative 4.4 W plus 19.96. All right, now I have a W on this side and I have a W on this side. So I need to get them to the same side. We can bring this one over here, or we can bring this one over here. Okay, so doesn't matter. When I say bring one over here, I don't mean to just erase it and write it on the other side. I mean to use inverse operations. So let's go ahead and I'll bring this one over here. And what I mean by that is I will use the inverse of subtraction, which is addition. So I'll write plus 12.9 W over here and plus 12.9 W over here. That cancels. We have negative 37.84 equals. Now we have different symbols subtract. So that would give me 8.5. And take the symbol of the larger number. So 12.9 is bigger than 4.4. So that's going to give me, and the 12.9 has a positive symbol or a plus in front of it. So I'll put a positive 8.5 W over there. Or in fact, we don't even really need to write the plus sign. We can just leave it like that. Everything else stays the same. So plus 19.96, we're just copying that down there. Now let's subtract 19.96 because we want to get the W by itself. So we'll subtract that from both sides. So we have 8.5 W equals, again, same symbols add. So let's just do it in the calculator here. It's easy enough to do it by hand. So 4 plus 6 is 10, carry the 1. Then I get 1 plus 8 is 9, plus 9 is 18, carry the 1. 1 plus 7 is 8, plus 9 is 17, carry the 1. 1 plus 3 is 4, plus 1 is 5. Make sure that the decimals are lined up. So I just added here. Same symbols, add, and keep the symbol. All right, now my last step is going to be to divide both sides by 8.5. I don't know if you can see it. I'm going to divide both sides by 8.5 to cancel this out over here. And I will use the calculator for that. 57.8 divided by 8.5. Okay, 6.8. But I do have to remember that this was a negative divided by a positive, so that would give me a negative. So negative 6.8 for my answer. Okay. All right, this looks to be about the same. I'm going to jump to the next level. And, oh, I was so ready to just say, oh, it gave me the same kind of problem so I can end the video there. But, oh, I have to do another kind of, it gave me parentheses and it didn't give me any parentheses before. Okay, so let's try that. 1 second here. Okay, so here we go. Negative 19f equals negative 4f minus 5 times negative 5f plus 16. Okay, let's begin by distributing. So don't forget about this negative. It's technically a minus, but just treat it like a negative. So we have a negative 5 times negative 5 is positive 25f. And negative 5 times positive 16 is negative 80. Okay, negative times positive is negative. Everything else stays the same. So we have negative 19f equals negative 4f plus 25f minus 80. Now, since these two terms are on the same side of the equal sign, we can just combine them straight away. So negative 4 plus 25, different symbols subtract. 25 minus 4 is 21. And take the symbol of the larger number. 25 is bigger than 4. It had a plus in front of it, so we'll make this a positive 21f. Then don't forget the minus 80. equals negative 19f. Nope, I have an f, whoopsie. Okay, so now I have an f term on the right side and an f term on the left side. So I want them to be on the same side. Now, this is what I was saying before. I could bring this one over here, or I could bring this one over here. But if I bring this one over here, then I'm going to have an f term together with a non-f term. So I might as well bring this term over here so that in the end, on the left side, I will only have an f term, and on the right side, I will only have a non-f term. So there's an invisible plus sign here, and the inverse of addition is subtraction, so we'll subtract 21f from both sides. Same symbols, add. It's going to be 40, and keep the symbol, and also keep the f. Now we'll subtract negative 40 from both sides. So f equals negative divided by negative is positive, and 80 divided by 40 is 2. So f is equal to 2. Again, you could plug the 2 back in everywhere that you see an f, and you would see that both sides would turn out to be exactly the same. You would get negative 38 in the end on both sides. All right, so let's do this one. Okay, let's begin by distributing. Negative 2 times negative 13 is positive 26. Negative 2 times negative 19 is positive 38. And then don't forget there's a t over here. Equals negative 3 times negative 8t is positive 24t. And negative 3 times positive 10 is negative 30. Now let's bring the t's to one side. I'll put the invisible plus sign there and then subtract 24t from both sides. Remember, I'm not going to subtract the 24t from this term because this term does not have a t. I'm going to subtract it from this term because this term has a t just like this term does. So minus 24t cancels. We're going to get, what, 14t here. So 26 plus 14t. Because 38 minus 24 is just positive 14. So now I have 26 plus 14t equals negative 30. Let's get rid of this 26. Now we have 14t equals, same symbols, add and keep the symbol. And then final step, divide both sides by 14. A negative divided by a positive is negative, and 56 divided by 14 is 4. So we get t equals negative 4. All right. Same idea for this problem. So I think I'm going to end the video there. Hope that was helpful. Reach out if you have any questions, and have a great day.